Okay, now go ahead. Excuse me, hello. Can you please louder? 6.7, number 9. So do you have the problem itself? Can I have the paper if you have the question? Number 9. Okay, this is a good one. This is, we tried only one example, very similar, right? This is the only example we tried it. The last one, it's similar to this one, but the only main difference that we see is 2 of these functions are piecewise. Mine, one of them was piecewise. The example that I tried, only one of them was piecewise function. This is both. And this is GOF. They are both from Z to Z. Z to Z, and this is number 9. I don't know, number 9 section. Do you know what's the section number? Okay. Let's see what we can do for composition of these two functions. So your inputs for this one is for f of x. So you are deciding about your inputs, which is f of x, okay? So that means when you're having g of, which your function is over here, so you're having g of f, so you have to decide about what would be the x's coming from. So I'm going to write down my scratchbook and find out what is it, right? So if you plug in f, so you have 2 cases. So you can either have g plug in 2n minus 1, or you can have g plug in 2n. If your n is bigger than or equal 0, if your n is less than 0. This is okay? Do you agree by now? Your input for the function of GOF for now is only f of x. So you're having 2 cases. You can plug in g for the top function if your n is positive. You can plug in g for the bottom function when n is negative. So is that okay by now? Can I continue? Okay. So next step is when you are making your g of 2n minus 1. When you are making g of 2n minus 1, so then you have 2 choices, whether 2n minus 1 is even or odd. What do you think? If your g, your 2n minus 1 is even or odd. If it is odd, you have to choose the bottom one. If it's even, you have to choose the top one. What is it? 2n minus 1, is it odd or even? It's always odd function, right? So 2n minus 1 is odd. So you have to plug in g of 2n minus 1 for the bottom one. Okay, we can write down over here, since 2n minus 1 is odd. And then g of 2n. So if your n is negative, so you have to plug in the g for the top one because n is your input, so whichever number is input now is even number. So then you are having 2n, let me write it in color, 2n replaced by n, and then you have plus 1. Okay, that makes sense? Question on this one? Any other homework question? Any other question from homework?
Yeah, I have one that I think I was confused about. It is number 51642.
I have to have the numbers, because it just bringing the textbook, for some reason, it takes really long for me to load. So if you can give me the problem itself, that helps.
So the function is n cubed plus 1. And we have to figure out whether this is a one-to-one function. And,
n cubed plus 1.
N cubed plus 1.
One-to-one and?
Just determine whether it's one-to-one. I had a question about my process. So in the book, I don't think this is, I can't remember if we went over this in class, but in the book it said you could take the derivative of that equation. And if you take the derivative, so f prime would be 3n squared. And it said if it's increasing or decreasing for the interval, and it's either always positive or always negative, then it would be one-to-one.
Okay.
If I'm remembering it correctly. Does this sound familiar?
Yeah.
And this derivative, f prime of x, so 3n squared, at 0, it's 0. So it doesn't fit that definition. I just wanted to make sure that because I could show that case, I can prove that it's not one-to-one, and I can bring that counterexample.
What's wrong to be 0?
What's that?
What's wrong to be 0? So first of all, what was the domain and codomain for this function?
It is z to z.
Okay, z to z.
So I was looking at the definition, and it says, so hands-on exercise 6.3.2, it says you can use calculus to determine if the real function is one-to-one. The real function f is increasing if this, and then over an open interval. If f prime of x is greater than 0, but not equal to, for the given interval, or if it is less than 0 over a given interval. It does not say equal 0. So for this case, if you plug in 0, I'm sorry, this is x and n, but if you plug in 0 for n, then it is equal to 0. So I'm trying to figure out if that trick works or not.
Okay, so first of all, let's just cover that one because we didn't cover here, and we were fine to do the exact method that we did in the class. So this is extra one, okay?
So it's supposed to be f of n. My bad if I said f of x.
No, you didn't say anything. You just said n cube.
Yeah, sorry about
okay. So first of all, let's add this one to the note. If you want to just add it over here, there are several ways to show something is one-to-one. So one way was just that horizontal line test, right? So that shows this one-to-one. One way was the just definition, right? So you just say if the images are the same, so you said the inputs to be the same, you end up to the input to be said the same. Actually, that works for this one. So if you just go by definition that we have done in the class, that works exactly with this definition, and you can just show it the same way that we did in the class. This is the one-to-one, okay? So I have to add a few things over here before starting to do your method.
Okay.
So again, remember this function passes the same two methods that we did in the class. Horizontal test, yes, it passed because it's a Q function. It looks like this. It passed the horizontal test. And then if you try it by f of n1, set it equals f of n2, and then just do the process, you end up with the n1 equals n2. So it passes both those methods. So I'm talking about the third method. So which you're just trying to do it, and then your question is about n equals 0. So first of all, I have to remind you what is increasing, decreasing function. If you're you starting with the, let's say x1 is less than x2, and you f both sides, then this is increasing function. So if you have x1 less than x2, but then the values are just really following the as your x's are increasing, your y's are also increasing. That's what we call increasing function. And then for decreasing function, it goes backward, right? So when your x's are increasing, so your f of x are just going backward. So it means you switch the inequality. So this is called decreasing function. This is called decreasing function. And then if I call it, I can't call it definition. Basically, what you're trying to say is a theorem. Theorem says if the derivative of a function is always positive or always negative, then the function is one-to-one. Or you can just say increasing, decreasing, function, or one-to-one. Okay. The other theorem that we try to do is really calculus one theorem. If derivative of a function is positive, then f is increasing. If derivative of a function is negative, then f is decreasing. And we know if the derivative of function equals 0, we have a max and min, right? So that's just something that we have in. We have a max and min. You have to complete it. If derivative a function is 0 at any point, there exists either a max or a mean at that point. In calculus one, we call it critical point because it could be either a max or mean, or maybe even if your derivative undefined. So that just really, this green one is really calculus one.
Is it, so what I would prefer for this problem specifically, would you call that a max or a min? I thought it was called the inflection point because it's neither a max nor a min.
That's actually a good question. So what is the inflection point?
Where it changes from increasing to decreasing?
No. From upward concavity upward to the so it's the place that your second derivative changes the sign. So the second derivative changes the sign. Okay, so that's inflection point, but it has nothing to do with the max and min. No, it's not max and min. Okay.
Okay.
Because actually this function is always increasing, so it can't be any max and min. So one more time, we already know from the algebra classes how the graph of n cube is.
Okay.
Do you agree with that?
Yeah, that's what I thought, but I looked at this theorem and it says decreasing over the open
Okay,
interval.
so-
And it says not equal to 0. So I was confused by that.
Mhm. So your f of x is n cube. Oops.
Yeah, 3n. Yeah, f of x is n cubed plus 1.
Sorry. F of n you said is n cube plus 1, and you have 3n squared for the f prime of n.
So that would just look like a parabola.
And this is always bigger than equal 0. This is always bigger than equal 0. That means your function is always increasing.
Okay, is this written wrong then? Because it says explicitly not 0. If it would have said, if it would have included 0, then I would have known the answer. This is why I'm asking. It's on page 166 that this rule is outlined.
That's a really good question, because you see, specifically about this question, because it's really clear that's one-to-one. For many reasons, it's clear one-to-one. So I have to explain something else. How do I explain? Because it's calculus. Okay, let's think about like this. If just about the cases that n equals 0 might be a problem. Okay, so about the cases n equals 0 might be a problem. Okay, so for here, that's just not this example. I'm talking in general. Why n not to be 0 is part of that theorem. Okay, so think about if you're having just always the positive number is going up and up, and then you're just making some max point, and then you're back then down. Okay, so the problem for having zeros, the problem in having zeros or getting the highest point and lowest point is if you're making your horizontal test, you might get 2 intersections. Okay, but for this case, for this problem, I don't have that issue at all, right? So if you have such a this graph, there is no such a case that you're having going up and down, or making 2 max or 2 means, or just making 0 to be a problem. So it's always going up, passes horizontal test, or it's just there is only one single intersection which shows corresponding which each images to be the same. Your inputs has to be the same. So 0 is not a problem. Not a problem. Okay, so I have to see about the domain and codomain in that theorem.
Says 2 to infinity here for this one. And then it outlines, you can take the derivative and a function increasing over this interval. It says f prime of x is greater than 0, or it's decreasing if f prime less than 0, or whatever interval. So if the 0 wasn't a problem, I would have said, yes, this is always increasing.
Where does it say that the 0 is a problem?
No, for this one. That's why I was saying, if you graph f prime of n, it is always positive other than 0.
Okay.
So that's the
But the theorem
thing that
doesn't
I'm
say
bringing.
about anything 0 is a problem. That's a definition of being always positive or negative, right?
So if it's always positive but includes 0, is that
That's
still
okay,
always
yeah.
positive?
That's a still increasing function.
Okay, yeah,
That's
that's all I was asking. If 0
So
was
I-
included, then
Yeah, no. So I thought specifically in the theorem, it's written if you are having, no, that's definition, that's exactly the same thing that I wrote over here, right? So it's what I am saying. So it's a positive is absolutely going up, or just really have no stop all the way to the infinity. If it's negative, is absolutely going down. There is no stop. So because there are some functions that are going up and down, but this always positive, including 0 means going up, always negative, including 0 means going down. So it
Okay.
means just increasing, decreasing.
I'll include 0 then.
Okay. The only problem you might have with the 0, as I said, is if you have 2.
2 roots, that is, but 0
So-
at different points.
Yeah, that would be
I
a
mean, in
problem.
that case, it wouldn't be 1-to-1 anyway, right?
Anyway, no.
Yeah.
No. But again, that was a really good question to do some other types of problems because so for I think we did this problem for natural log or something like that, right? So if you're checking your problems again, have I had like just this example? I think we tried it with actually we have had this very similar one. We tried it with just the same definition, the original definition of if the images are the same, then the functions must be the same. So exactly this problem, I can go with the original definition of if you're having the images, sorry, this is K. If you're having the images are the same, so then your output, your input, sorry, must be the same. Okay. So what is the alternative way of doing? I can say easier way of doing. I'll say, okay, since this is a function that's always defined in positive, and if I take the derivative of this function, which we all know what is the derivative of this function, and for all of the x's which are positive, then the derivative of your function is going to be always positive. So that's enough. That's enough to say this function is one-to-one. So again, that's alternative way, right? So for some problems, you might think it's easier, but for most of problem, the original definition is perfect. So you can use it. But that was really good question to remind you from calculus one, you know what's increasing, decreasing function. And based on the graph, increasing, decreasing function passes the horizontal line test. So they are going to be one-to-one. Okay. That was the only question. Please.
Okay, so going back to the original question that you guys were working on, that's one-to-one, but it's not on-to.
Again, depends on what's given as the codomain, right?
Right.
So your codomain is from the integers to the integers, right?
Right. So it's not, there would be not on.
Can I try it? So actually it is.
It is?
You can just think about the graph. This is very simple to think based on the graph. It goes all the y values, possibly, yeah? So you can have any y values because it's stretching in y direction, right? But if you want to try it, you have to write it by definition. Can I? Let's say, in order to show onto, we just say for all y's choosing from the codomain, there should be one x choosing from your domain that f of x equals y. So a little bit side work or scratch work. So you're having your y equals n cube plus 1. So you subtract 1, and then you cube root both sides. So this is your side work. So you can just say, if I take, or you can just maybe use the let y to be arbitrary from z, then take x equals third root of y minus 1. So f of x is f of third root of y minus 1, which is going to be third root of y minus 1 to the power of 3 plus 1. So which is going to be y minus 1 plus 1, which is going to be y. So that's proved, right? For whichever number, because the inverse exists basically. Because the inverse exists, whichever number I choose from the y, there exists one x that is root 3 of y minus 1.
So if the domain is a set of integers, does it have to cover all the integers to be onto, or it can be just specific? I mean, it just has to include some of those. You know what I'm saying? Onto means.
That's a good point. That's a good point.
It has to be.
Because you have integers, huh?
I was gonna argue the same issue.
Yeah, because third root, that's a good point. Thank you, Thomas. So that's exactly a good point, because you're saying if, how do I know if y minus 1, the third root is going to be giving another integer?
Right.
That's a good point, yeah. So this is not onto, yeah.
Yeah, if you do two, then it would.
Mhm. So since,
If it's the real numbers, I think it is.
yeah, that's a good point. Thank you. Because third root of y minus 1 is not always in Z, or what we call the domain.
This is what you were talking about, and you have to be careful because with discrete, you're talking about exact values, not
Discrete map,
the
yeah.
continuity of the graph.
That's true. That is true. Thank you. That was just really good point because we have to always be careful about this is a set of dots, not the actual cap. It's really a set of dots on that form, okay? It doesn't cover, not necessarily an integer, so that was not covered. You can bring counter example, right? So we can bring one counter example, which y minus 1/3 root is not, that would be enough. You don't need to write this proof, right? So this is if you write it in proof, in alternative way, you can bring infinite many example that say, if I choose y to be like 3, then 3rd root of 3 minus 1, which is, what was it, 2, is not integer. So that means for y equals 3, there exists no x that is the images of the 3. But you can bring counter example. Either one is fine. I think counter example is always easier than proof. Any other question?
I have a question. So what we're doing today, that's gonna be on the exam.
Yeah, because we covered it in last class, yeah.
Do you think you can make an extension to tomorrow? Just today we're finishing up the 6.7, just so we have time to kind of review it before we just rush into homework.
You're talking about the extension of your homework.
Yeah, because 6.7 is on Friday.
You know what? Yeah. What is the due right now?
Yeah.
Oh, that's okay. That's okay.
6.7.
As soon, as long as you're doing before the test makes sense. If you do it after the test, it's really zero credit, okay? Because what you've been a student for years. You've been a student for years. You have had several math courses, right? Does it make sense to do homework after midterm? It doesn't, right? That's really clear. It doesn't. So I'm not going to change the dates, but as long as you're doing before the test, it's fine. But you have to spend a little bit time on the exam itself, right? So because you have to review all of your lecture notes, you have to review all of your quizzes, you have to review all of your worksheets that you have done, and that takes at least a night, right? So if you want to stay for another, it's not really you because I've had several emails. I have had emails really about the homework, and I explain every single email. If you do your homework after the test, is no use. So if you want to do it, or if you want to use it for the test, you have to do it right now, okay? So I will say Monday to tomorrow night is fine, but just remember, you have still a full day almost because we have evening class to study for the actual other sections, because 6.7 is not the only section in the test. You need time to study, okay? So I'm okay to do it later.
So you are going to extend the due date for homework until tomorrow night?
I'm not going to do officially, but if you submit it later, before the test, I'm fine with that. After the test, zero.
And it will, campus will allow us to do that?
Yeah. Okay. So let's just check what we're supposed to do today on the modules and then check your comments. I don't think I have really brand new topic to cover, but I just want to make sure because we have done all of the sections which is in the test. This is inverse function, and then so you see, the only thing we want to do is more practice as we have done right now for some examples, and then more practice with the same concept of the inverse, and then one-to-one and onto. So that's what we want to do. So this is the first time I'm just recording this class. Always I record the other class and share with you. Now I'm just going to do with your class because I'm really happy about your class. You are always asking questions. They're always just watching me like this. So I like your class. So I think this is more useful for just recording these questions. And thank you for asking questions. Okay, great job. Let's just jump to the questions first. If you guys have any feedback for me from the previous, I know for onto, mostly for onto is more challenging to one-to-one for the because we haven't covered in algebra or calculus classes what is onto. We always talk about one-to-one because we need the inverse. So we are in week number no, really. Should I have anyone like Aaron, Alan, and Matt to write the comments for me? How come?
This is you perfect.
I need those comments, guys. That doesn't make sense. I know what this is week 7, right? Can you believe it's week 7?
Yeah, that's great.
You see, have you received this one? Have you guys received this email, the announcement?
Yeah.
Aaron,
Yes.
Alan,
Uh-oh.
did you know you need to write some comments for me?
That was in the end of the week.
What do you mean?
I thought that we pulled those questions out.
You mean on Wednesday?
No, like this week.
I'm pretty sure it has a due date on it.
So yeah, and you see, when we have a week number 7, we have to just put, so that's what it says over here, right? So this, we are now in week number 7, the comments is for week 6, the previous topics. So that's what it says over here, right? So we are in week number 5, so we need to talk about the previous week. That's why it's starting from week number 3. So then you have the previous week, which was week number 2. So that's what it is. A reminder is for this week, but then you have to write about the previous week. Okay, does it make sense? I think that would be really helpful if I have some comments here. Okay, so for now, we don't want to waste the time because Wednesday is the midterm. But you guys need to know, as soon as you get the announcement, just click on that link because that's a hyperlink and just start to write what you have learned in previous. That would be really helpful for me and for you. For me, because I know what's the feedback from the class, for you, because that's a good review. Okay, so let me move on. Let me make sure, what did I practice for? I think we have to practice the modulus. Okay, so let me just do that one first. I'm adding examples for the topic. Okay, so unless you don't have any question, any question, any more questions here? Any more questions here? Yes, please.
Actually, could you go over modular arithmetic a bit more? Because I was kind of struggling with it more.
You mean more examples on the modulus? That's what I'm going to do right now. I have several examples to try several things like being one-to-one onto or finding the inverse function. Okay, so this is.
I was looking at examples with the modular, and you think it would be, if we're gonna do the modulus examples, that we could either make, even if it's just like a few values for, on like a chart, or, I'm not sure if it would be appropriate to like graph what we're seeing, but if it is, could we do that? Because I think that would help.
Modulus?
Yeah, but I definitely saw at least the chart where it says, all right, if I plug in 1, this is what I get. If I plug in 2, this is what I get. But I'm not sure if charting the modules would be appropriate. because I
For
kind of
which way?
visualized it.
Onto or one-to? Onto or one-to-one? We haven't used table in our book. I mean, our lecture notes or examples, because we can always show it in general way. So that's, if you're looking for counter example, yes, that makes sense. If you want to disprove is one-to-one, or if you want to disprove is onto, that's one-to-one. Okay, so that makes sense to use the table, the values, because you can see if the images are the same, whether the inputs are the same by the table. In general, I don't think we need to do, but we can try one example. Just bring one example up over there. So as I'm doing here, just let me know which one I can try with the table. So again, as soon as long as I know I have one-to-one and onto, the way that we just do or prove, that's perfect. But if you want to disprove or just fail to be onto one-to-one, so then the table works. But still, I don't need all values. It's kind of wasting time, huh? But it still is okay.
Honestly, it's more for demonstration purposes, just to kind of conceptually, okay, this is what we're doing for mod, if that makes sense.
Bring one example, please, if you have
I'll
any.
try to look for one.
Okay. Let me make sure which examples we tried. I think we tried only 1 or 2 examples. For modulus, which one is this one, huh? The 57 one, and that's it. Yeah. So we tried one more. I'm going to try here more. I have my function, which is from z sub 15 to the z sub 15. And then this is given by 4x minus 11 in mod 15. Okay, so if I want to make a table, this is asking me whether this is one-to-one. This is one-to-one. So you can ask, so first thing that why I feel I've done this one. Did I try this one in your class? Oh my God. Sorry. Thank you. I totally forgot about that.
Yeah.
Okay, so we tried this one. So that means we tried this one. Okay, and let's just change it because we tried this one. I don't know why I couldn't see it, but you tried this one, right?
I'm sure if we tried that exact one, but it was similar.
Yeah, they're always similar, unfortunately, right? Anyway, if we try this one, we can try one more. That's not wasting time. So you are having the h is defined from z sub 23 to the z. Oh, that's why, because I wrote it on the board. At that day, I haven't had my tablet charger, so I had to write all on the board. So that's why I don't have it over here. Yes, we did this one in the class. This is asking whether this is onto. Is h onto? Okay. We can try the table of value if you want. So I think that would be just good practice, but not for all values, right?
Yes.
So your you can call it T table. It's really the same as a T table. So what you have, you just want to put the x's over here, and I want to just put h of x's over here. So the values. Why it's so slow? So you can try for inputs starting from 0, then 1, then 2, then 3, then 4, then 5, 6. You can continue really by 22, right? So there are z sub 23 is included. So let's write over here to remind you all of the remainders when you divide by 23. So it's going to be 0 all the way to the 22. So then h of x for h equals 0 is going to be 5 times 0 plus 8 in mod what is 23. So your 8 over here, h of the 1 is 5 plus 8 in mod 23, which is still 13. H of 2 equals 5 times 2 plus 8 in mod 23. So that is 18 for now. And then we need to just be carefully past the 23, right? So if you have h of 3 equals 5 times 3 plus 8, so then you have mod 23, 15 plus 8 is 0, right? Is that okay? So if you have h of 4 is 5 times 4 plus 8, 28, 5 left, right? In mod 23, and so on, right? Should I continue? It will repeat somewhere, right? So you know back to the same number. So like now you have 8, 13, 8, 13, and then 18 and 0 and then 5. So if you get all of the 23 numbers, it for sure is repeating back into the same, what was it, 8, it backs to the 8 again, and then all of them is repeated. So that's the last one we tried, right? 25 plus 8 is 33. Remainder is 10, right? Am I right or no? So the remainder is 10.
And it just goes by 5. Because that's the only exercise. It's all multiplied.
Mhm.
This, by the way, this is already a million times more clear than like most of the mod examples that we've done, just because I can see what's happening now. So this is what I was asking.
Okay, great. Thomas?
This is the preferred way of finding, onto, like, in the
It could be, right? That's just the third way you say, right? The third way was the first one is definition, which for every single y you have to make sure there exists one in the thing, or you can just say the graph is one way, right? To make sure it covers all of the y values. And then
I can see myself doing that, but probably,
this one is faster.
filling out the chart.
This is the faster one for you.
It's clearer. and it makes sense.
So then I can do the algebra part too. So we are looking for the algebra and this one. So how do you figure out from the table it's onto? Can you explain?
To be honest, I put an Excel sheet. not just- I did it like on
Good
modules.
answer.
Okay, no, that's okay. You fill out the numbers, and then what is the whatever argument you can bring for me, this table shows this is going to be onto. That I'm looking for that word. So
I'm just thinking for the exam, obviously I won't have Excel, so.
we won't have Excel, but that's just really to complete your third method. So if I just want to complete your third method, if your second row, which is the values of your function, which are your y values or your codomain, covers entire number from 0 all the way to 22, then you will say this is onto. Okay, so that's your argument. You have to bring down to here, say, okay, since my y values or my output are all the way from 0 to 22, or it covers all entire codomain, so I have onto function. Okay.
You remember when I said I was gonna crash if we did a mod question? I understand what we're talking about now, because you said the 0 through 22, we did the chart. I understand.
Okay. I'm okay to just write the actual solution question here. Okay. So just back to one of the examples we tried for onto, we can just redo the same thing. We see the process of being onto. If you remember with this example that we just did for NQ plus 1, or this example that we tried it right over here, you see? That's the same process. We have to consider for every single element that I choose from the codomain, there exists one element from the domain, which the image is that. So then you take the arbitrary elements of your codomain, and then you just do a scratch work to make sure what would be the inverse of that. And then you can just say, okay, yes, for every single B from the codomain, I have one X or A from the domain that satisfy the equation. Okay, but you have to make sure this is part of the domain. Okay, which for the n cube wasn't, because the domain was integers. Okay.
So if I give you a fully filled out chart and I use the definition and I said, hey, look, I can.
Yeah, if the numbers are smaller, it makes
Yeah,
sense.
if it's
Like
10 or something.
10, yeah, 12, 15, it still makes sense. But if it goes 57, like the
Yeah,
other
no,
problem,
I
that
understand.
doesn't make sense. Okay. But yes, that's the solution. Why not?
Okay.
That is acceptable solution. Okay. So I need a little bit of scratch work, as I said, because I need the inverse of this function. Okay. So what do you do if you're looking for the inverse? Can you remind me? So you put the
variable.
y equals 5x plus 8. So x equals 5y plus 8. Then division doesn't make sense in Z. Division does not make sense in the Z. Right, Z is not included 1/5. Z sub 23 also does not include 1/5. So what is the inverse of 5 in mod 23, right? So you have to find whether there exists any number, if you multiply by 5, that gives you 1 in mod 23. Whether I have 9, but 9 give me -1, right? 14 works. I remember that there was one more. What was it? 14 times 5 is 70, minus 3 times 23. Yeah, that works.
Yeah.
So okay. So if I continue my method or just finding the inverse, you have had 14 multiply both sides. You have had 14 multiplied by both sides, and then you're getting what you want, which is y by itself on the left side. Y by itself on the left side, and that's the reason on top in mod, what was it, in mod 23, sorry, thank you. So then is this enough to say this is on 2? I have to write the argument, right? So I have to write the argument over here saying actually f inverse of the x equals, was it f or h? H. X equals 14 times x minus 8. Okay.
What was that? Filling?
There are 23, 0 to 22, or z sub 23. Okay. So you have to say for all b's choosing from z sub 23, there should be one x choosing, or a choosing from z sub 23, such that f of a equals b, right? Oh, sorry, h. H. So then, according to that scratch board, if let b to be arbitrary element of z sub 23, choose a to be 14 times of b minus 8, then equals h of a equals h of 14 b minus a equals 5 times of 14 b minus 8 equals 1. So it's b minus 8. Oh, sorry. It has 5 plus 8 at the end also, equals b. So I have to make sure, since 14 b minus 8 is in domain of z equals 23, so that works for b's in z 23.
Professor?
Mhm.
I'm not sure if anyone else in the class has experienced it, but I am not familiar with the rules with division and subtraction. This is the first time that I've ever seen any rules like that in mod 23. So just real quick, you can add and subtract just fine in any mod, and then but you can't divide, so you have to do the there has to be, to divide you have to find
Multiplicative insert
the
inverse.
multiplicative inverse. Is there any other ones like that? Like, is there like a square root rule or anything like that?
Same. Whichever operation doesn't give you the integer, right? So because if you have a 2, square root of 2 is not integer anymore. So then you're not allowed to do on that equality sign in mod.
In one? Okay, so this doesn't work.
So
It's like dividing
addition,
by zero, isn't it?
nothing else, only addition subtraction works actually.
Oh, okay, got it.
Can you show me really quickly how you came up with 14?
It is,
Because I know that you were calculating something.
How did you get?
Actually, I was going to ask him, how did you guess it's 14?
Since we were dealing with 5, it's very easy to know when you're close to a multiple of 5. I was looking for, so I just quickly kind of went through multiples of 23 in my head till I got one that was one less than a multiple of 5. And it just happened that 23 times 3 is 69, which is one less than 70. 70 divided by 5 is 14, therefore 4 would be the increase.
hey, real quick, am I the only one who's never seen these rules before?
That's why you are passing a course called 270A. If you knew things why you are here, so you're learning, right? So
I think the first time you went over it, it kind of seemed like, oh, you guys know this. And I was like, no, I don't. Yeah, it was just.
Can you say again about 14? Still confusing.
yeah. So the thing is, for me, it was just really looking for a number. You have to look for a number when you multiply. So the number has to be, for sure, this is really clear. The number that you're looking for, it has to be from 0 to 22. You're looking for one number from 0 to 22, which you multiply by 5, divide by 23, your remainder is 1. Okay, on calculator, what did I do on calculator? So I was just, when he said 5, so for me on my note, I knew I have a wrong number, so I have a 9, okay? So what do? I just say, if you multiply 14 times 5, if you multiply 14 times 5 on calculator gives me 70. And then I was just guessing, okay, so which number of 23 is close to the 70? So as what I was thinking. So I was thinking, so which multiple of the 23 is the closest to 70? So I was thinking, okay, 2 times 23 is just 16. 2 times 23 is 46. So it's so far from 70. So then 3 times, I was just checking on my head, 0 times 23, no, it's far from 70. 1 times 23, no, it's far from 70. Then keep going, 3 times 23 works, right? So then it's 70 minus 69 is 1. What?
That's not the first number I would be thinking of. So I don't know how, I mean. So I'm multiplying some number by 5 to get 70. Where does 70 come from?
So why do you have it? Why do you know it's 14 multiplied with 5?
So again, your choices start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 to 14. Okay. So if you want to start from the beginning, that takes forever, right? So that's why you have to just have some idea, like what he said. He said, since it's multiple by 5, so multiplication of by 5 is only the one that ending with the 0 and 5, right? So then whichever like number like 4 times 5, it gives you 20, which ends with the 0. That would be just a good choice, right? So like starting from the beginning, so 4 times 5 is too small. Maybe 9 times 5 is still small. So you have to try the numbers, right?
Yeah, basically I just went through multiples of 23 in my head, so I got one that was 1 less than a multiple of 5.
Oh.
So I quickly figured out 3 times 23 is 69, which is more than 70, and used that to figure out it had to be 14.
Wait a minute.
70.
Oh,
Okay.
I'm okay right now, Thomas? That makes sense? Okay. So your actual sorry, we have so much information on this page. So this is because you were asking different question. Okay, so this is not the answer of my question. My answer of question was over here to here, right? So because you were asking something, I explain over there, okay? Make sense? Question? Just notation wise, if you see anything like, you see notation wise, if you see something like if, you will see in your homework, if inverse of a set. So it's the set of all XA, if X is in the domain, okay? So that's just notation wise, like just, I'm bringing example to explain. If you see such a this maybe notation, my function, my example is defined from the domain is 0, 1, 2, and your codomain, actually no, it has cross 1, 2, 3, and then to the Z, this is saying F at A and B equals A plus B. So the question asked me, what is the image for function F? What is the value of your function for the set of 0, 2, and set of 1 and 3? And then F inverse of the 3, and then F inverse of, I think for this one table helps because it's not that much. It's not that much, so it's really 4 elements, sorry, 3 times 4, 8 elements. So that makes sense if you make the whole entire table. Can we try it? What's the image of this function? What's the possible image of this function? I'm going to make what's possible the domain. So you can have a 0 with do you like the table or no? So you have 0, 0, you have 0, 1. You know how to make this one, right? This is fine. This is okay or no? 1, 0, 1, 1, 1, 0, 1, 1, 1, 2. Is there anyone doesn't follow what I'm doing? Is there anyone can't follow what I'm doing? 1, 3. And then I have 2, 0, 2, 1. For some reason, it doesn't work.
Your iPad like really hot.
Mm.
Okay, like overrun.
What's the solution to make it cold? Do you think this way works?
Probably close on- If you have multiple things running, it'll make it run really hot. So you have to close everything out except, what you're using.
I have really 2 of them using, right? Hmm?
He said if you give everyone A's on the exam, that it'll.
Oh, yeah, sorry. So 2, what was it, 2 and 1? I'm not going to go to the next line because I just want to write underneath. So this is 2 and 2 and 3, okay? So what is the image of the function for each of these ones? So look at the definition. It says F at A and B is addition of the components. So your possible images is 0 plus 0, 0 plus 1, 0 plus 2, 0 plus 3, and this is repeating. I have a 4 also, and the most is 5, right? Do you agree with my image? Sorry.
This is essentially all the possible values given that function.
You don't, that's your possible output, or possible y values or what we call range or what we call image.
Well, I think of this as a three-dimensional function. Like I try to visualize it and am I thinking about it in the right way? So for this, it would be the possible z values, but it would be,
The third dimension.
okay.
Not the third. So then the one more time, the problem is this is the set of dots, not the
Yeah.
actual surface.
Yeah. I understand.
Okay. So what is the value of the function for 0, 2, and 1 and 3? 2 and 4? What's the F inverse or which inputs gives you the value of 3? 0 and 3? 1 and 2? 2 and 1? That's it? So which two numbers add up with the 3 basically, huh? Based on this definition that's giving you. I have F at 4 also, which is really similar. Is it okay? How the problem works or what's the notation of F inverse?
Can we check the first function again? Because the possible outcome is not defined in the first section. It's 4, it's is that still function 2 and 4? Because the 4 is when we check the question, the first line, the 4 is not defined as a second.
No. Remember, your outcome is this. That's a really good question. Thank you for asking. So this is the whole thing is your domain, and this is your codomain. So your inputs are this.
The question says, when we put those information, we have income for f function has to be 2 and 4, right? But there is no income assigned.
No. So that notation on top means your outcome has to be 3 and 4.
But first, I'm asking for first function.
The first, you mean this one?
Yes.
Mm,
When we put 0 and 2, so outcome is going to be
2,
right? When we put 1 and 3, outcome is going to be 4.
okay.
But the function, it says input has to be 2 and 4. What is the outcome?
Uh,
Am I getting it wrong?
Yeah. So you see, you're starting from here. This is your input and this is your outcome. So it's possible to get your outcome any integer. So 4 is fine. So your input is just this and this. This is your input. Both of them are your input. And then your output is whatever is the addition of these two numbers. So you're saying we don't have 4 listed over here, but it's okay because this is your domain. You should have 4 over here, but your output is over here. So let me make it as a visualizing picture, like a Venn diagram. You see, your input to the output. Okay. So your input is just the product of 0, 1, 2 times 0, 1, 2, 3, okay? But your output could be any number. Does it make sense? Agree? So it could be 4.
So in the parentheses contain all the potential inputs. That's correct?
Mhm.
Okay.
So then, when can we have the output of 4? If your addition of your inputs is 4, which for 1 and 3 add up to the 4, 2 and 2 add up to the 4. And it's possible, okay? Any other question here? Any other question?
Need to go back. Go back. Yeah. Okay.
Still?
Yes. Yeah. Wait a minute.
Oh, you're looking for the previous problem
Yeah.
completely, okay. One more proof.
So when you write out the solution, you can write out like that, not like the sentence.
This one?
Yeah.
Yeah, this one, yeah. F inverse of D minus D2 is the same as F inverse of D1 minus F inverse of D2. This is connection between this chapter and set theory. This is the connection between this chapter and the set theory, okay? So you remember what was the equality in set theory, right? So you have to pick one element from the left side and you have to show is on the right side, and other just the opposite. So you have to pick one element from the left side and show is in the right side, okay? So if you're having one element in the image, then you're having one element in the image, so f of x is in the D1 minus D2. That's what we all discussing right now, right? So you're picking one element from the right side or from the codomain or from the range. So what does it mean? There exists one thing on the left side which f of x equals f of x is coming from your domain. Is that okay? Do you agree with this one?
You put parentheses in this, just so it's very clear. Is there no parentheses? Okay.
Okay, do I need it? So then I have f of x to be in the D1 minus, and f of x is not in the D2. Subtraction. So back to the definition, you can say x is in f inverse of D1, and x is not in f inverse of D2. If f of x is in D1, so that means there exists one x in the image of D1. Okay? So that means x is in f inverse of D1 minus f inverse of D2. Is this okay?
At the very bottom, not the one above that. How you got from f of x exists in D1 to x exists in the inverse of D1? Can you explain that to me, the logic that you use?
So you see your f is defined from D1 to whatever is the image, which is f of D1, right? So this is whichever element that you choose from D1, whichever x you choose from the D1, so then your f of x is sitting over here. How about backward? If you choose one element from here, so then f inverse of that is sitting in the D1. So now I'm using the same fact. I'm just saying f of x is in the D1. F of x is in the D1. So then what is the inverse? So then that means your x has to be in the images of your D1, right?
Okay. I see.
Any other question here? Question.
So you change it to that just so you can prove it, right? Or did that?
So x is an image is equivalent to say f of x is in the function itself. So think about, can you comment over here and just f both sides? So then you are having f of x and these two cancel out. So then you are having d minus d1 too. Does it make sense? I have to erase that scratch word, not the oranges, okay? Any question here?
Are we assuming that F is bijective?
Actually, because the way that is asked us is already proving, because F inverse is defined, yes, that's true. Yeah, otherwise we have no definition, or maybe we are not sure whether F inverse exists or not. So it's 2 by 2. So if you're having bijective, you know F inverse exists. If you're seeing F inverse, that means bijective, right? Okay. We're supposed to have one quiz today, right? Can we make that quiz on online?